Here's problem 23-7. If A is equal to 3 millimeters, B is equal to 4 millimeters, Q1 is minus 60 nanocoulombs, Q2 is 80 nanocoulombs, and little q is 30 nanocoulombs in the figure, what is the magnitude of the total electric force on little q? So here's Q1, and Q1 is actually a negative charge. So I can draw it. Here's Q2. Q2 is actually a positive charge. And then little q is a positive charge. So if we're looking at this, there would be a attractive force between Q1 and little q. That's called F1, going off to the left this way. And there will be a repulsive force between Q2 and little q, F2, going off to the right. And so these forces will be opposite in direction, and whichever one is larger is going to dominate. So we're going to have to find that out. Let's find the magnitude of these two forces. F1 is equal to K Q1 little q over the distance between them squared. That's going to be 9 times 10 to the 9 times Q1, which is 60 nanocoulombs, and we leave out the minus sign because we've already determined the direction. And we have little q, which is 30 nanocoulombs. All this over the distance between them, which is really little a and little b, which is 7 millimeters. And we'll square that. 10 to the 9 and 10 to the minus 9 cancel out, but let's just plug this into the calculator and figure out what we get. I get 0.3306 newtons. And that is going to the left like this. So that is our F1. F2 is equal to K Q2 little q over the distance between them squared. And that is 9 times 10 to the 9. Q2 is 80 nanocoulombs. Little q is 30 nanocoulombs. And the distance between them is distance b, which is 4 millimeters. And we'll square that. And let's again get rid of a 10 to the 9, 10 to the minus 9. And let's calculate that. 1.35 newtons. And that force is to the right. So we have these two competing forces, one to the right, one to the left, and the one to the right is larger. So we're going to go in that direction. So our net force on little q is going to equal F2 minus F1. That's going to be 1.35 minus 0.3306, and that's going to equal 1.02 newtons. And our net force will be to the right. So that's our answer. That's the net force on little q, 1.02 newtons to the right direction.